classification or anything. So we try to remove the stop word. So stop word is just articles and all this regularly used word that is not have very meaning in this one. So now this is also done. So a stop word. So for every language they will have, like in Hindi we will have kaki and everything. In Tamil they will have different stop words. So you can have multilingual support also. Now you have to see in NLTK how many languages are supported. Spanish, German, these all languages are supported. Indian languages are there or not. Some researchers are working on that and supporting that library. So that is the contribution you can make to NLTK if your language. So suppose you are from Assam or Northeast or some other state and your language is not supported in NLTK, then you can write all these things for your language. So that is one contribution many people are doing. So I am using English stop word, and again NLTK corpus I am importing the stop words, and then a stop word again is just a set and making a set of all the words English. So this is a stop words and I am printing what type. So this is all the stop word by default in English, and this is a set because I have put just in to a set, so this become a set, so it will have only unique value. So this is how you can import a stop word. This is English. So first you can use for your local language, in which language you are working, and if you want to add English new stop word, suppose I consider my name as a stop word does not have any meaning for my research, then I will add my name. So for doing that it is just a set operation, or if it is list then you can append as a list. I am using a set operation, a stop words. So here a stop word is this variable that hold my all stop word, and just I am adding my name as a stop word. So now it also added to this environment only, not to the library. I have not saved back this to the library. I'm just using in this environment. So this stop word is added. So now moving further. So once we have token and I have imported now a stop word. So next step is filtering. We can filter or cleaning the our token with the stop word we are using. So we are using English stop word. For that normal Python code you can just write W. So this part. So this is called list comprehension. This is very popular in Python, where we try to include condition and looping together. So this part is just loop for W in tokens. It means bring out every token one by one from token variable. So token, if you remember, token we have given the name that we have a split here. So this is the token variable, that is a list holding all the tokens. Looping it and then taking every word out, but not all the token if those token are not in a stop word. So this is the if condition. If not W means negation, that word W is not in our stop word list, then only include to the new list. So now this will do the comprehension, list comprehension, filter out our token with our stop word, and then now new token will have only the word that is not in list. So if you see, I have printed the first print. This is the earlier token without filtering, and second print is after filtering. So if you see, all the stop words have gone. Da have gone, and this da is there because I have explained this having uppercase and our stop word is in lowercase. So one thing is we can make our all text to lowercase and then we can do filtering. Otherwise we can do some other method also. So this is all your decision what you want to perform into your experiment. So you can make your text accordingly. So once we have done tokenization, we have done a stop word removal. Now next very important thing, and like most of time we do, is a streaming. So many people ask about a streaming. So it is very simple. What is a streaming? We have words. Say suppose working. Working is a different form of verb, and the root word for this is work. So we can have these two words, and if we are making some feature, this can be represented as a separate feature, and that will not give very good performance. So we try to remove this word and go to the root word. So this is, when I'm saying this look very simple, but when you go to the linguistic part of English or any language, this is very difficult job of doing a streaming. That's why many research have been proposed just for doing a streaming, and all the library have this kind of function. So very popular and very basic is Porter streamers, Leinster and Sonball. It is in NLTK. This is not only three. There are many also. Many new methods are also coming for different languages. In different language, this streaming will be done differently. So this is all one research area in itself. Just for example sake, I am using this Porter. Again, syntax is very simple, and this is all about streaming. If you are very interested, you can also look into this tutorial. I will just share to everyone. This is again everything about lemmatization and streaming. So I am using again Porter from NLTK. So NLTK, like every library will be organized in such way. NLTK for streaming, this one for other method, there will be other package, and then there will be module. So likewise it will be organized, the whole software packages, different job, and then the different function or module will be included. So I am just initializing our Porter here, and then again this print is just to showcase the without, before streaming and after streaming. So then I have created a stream variable that will hold only word after doing the streaming. Then looping again for all the tokens, we will take it and pass to the streamers. It will take the word, remove the extra word, and try to get the root word and return me the root word. That word will be appended to the newly created list. So this is the code. So if you run this, I think we have to run from here. I have not been running. Yeah. So just to run this, so we'll have all the value. Yeah. So now once you run this, it is doing uppercase to lowercase also, and it is doing the streaming also. So from jumps, it's become jump. Lazy, it is doing I, that is a wrong. So that is one kind of thing they do. Then we have another streamer, similar thing. We just try to get the object initialized, and then code will be very same, because we are just passing. This is the, it is like cutter. If we are using different cutter, just we have changed this from Porter to Langster, and then it will take the word, give the stream of that word, and again we will import. So this is different, not define, just define it. So this is done. Now there is difference between how Porter work and how this Langster streaming works. So both are different method, and their output will be different. Likewise, there are n number of streamers. Many new researchers for new languages also have purpose. So you can just try, if you are in linguistic or if you are in this kind of research, you can look more in detail. So that is two kind of things. Moving forward, I also tried to have more detailed example from previous link, where they have put lots of word and try to see how both these streamers are working. So if you are in this domain, you can have your streamers here, third one, and you can see football is wrongly done in both. So in your streamer, if you are proposing some streamers that can put it football as a football, means your work is doing good, it is proper. So likewise from linguistic or different language, so these are the research scope where people are working. So you have to think about in that domain. Otherwise, if you are building some application, some deployment, or if you are just making some product based upon this, then you can use which one is performing best, trying everything, and which one is good, then you can use one. So this is all about streaming. So I have just focused on tokenization and streaming. Mostly these two are must thing to do if you are doing a test processing. Apart from that, when you have a like noisy data, you have to do many pre-processing also, that I also show further. So feature extraction. So just to demonstrate how we make feature, I have included this example from a Stanford sentiment analysis data. This is very popular and like traditional data set from IMDb movie data set, sentiment analysis. So if you have downloaded that folder name, you can keep. So again, I have used all this text file. If you download it, if you see, this will be all text file. The data set, if you have downloaded text. So this is that data set. If you see, all these are like training and testing. So this is negative review, and I have just, this is all the text file. So this is text file. This is a story of a man, some movie. I have that review is given for some movie. So this is like that. This is the data set. If you are building your data set, it will also look like this one only. So how to take this file, text file, convert to Panda data frame and use for machine learning or anything. So that is from local loading local data. And this is like how you will start any your text processing research. If you are using very well-known data set, some of the library have already included into their package, so you can just import. But that is not what you will be doing in real world. In the real world, you will be collecting your own data set. I will show you after this how to collect your own text file for some particular problem. So then you have to do all the pre-processing cleaning by yourself, and there most of us are stuck and how to do, because most of the tutorial they will use the already existing, because there they want to demonstrate something else. They want to demonstrate tokenization, they want to demonstrate feature extraction, so that part will be missing. So you have to know how to load, and this is pure doing just Python scripting, nothing much. So OS is a module that help us to read the file from operating system local file and then manipulate and everything. Panda I am using for converting this text file as a row and column tabular data and then labeling. So and then this is just a variable folder name. Our label is I am just putting a dictionary where positive POS, if you see in that previous folder, the positive is used for POS, and I am putting that as a number 1, and negative I will say 0. This is just our labeling purposes. This is again a dictionary, and now I am just defining a data frame. So this is DF, again a traditional name used in Panda data frame, where we call data frame as a DF variable. You can use training also or train also, you can use that also. PD is the Panda data frame, and we are initializing. This is a initializing a null data frame, nothing is there. So now what we will do, our task is to go the all the folder. So if you remember our folder structure, so this is the folder structure. We have a root folder, ACL, this MLDB database. If you go to within that, we have two folder, text and train. In text we have test dataset, and in train we have train dataset. Within that we have negative sample and we have a positive sample, and some sample are like not processed. So we will focus on negative and positive sample, and we will have test and train data. So how we'll process this? This is very simple in Python because of this simplicity of OS. So for app in test and train, so this is just nothing to do with, you have just given we'll have text and train data, so it will do one by one for testing and then training. For IL in pose and negative, again just we are taking testing, positive, test, negative, train, positive, train, negative. This is just combination it will give. So this is no nothing involved, this is just taking set one by one. Now this line is very important. If you want to do any local file processing, you should focus more on this. So OS library, this is our OS module I have called. OS have this path function that have this join uh, function, where what you can do, you can, how in any file you open, that have to be a path, that how it should be accessed in your file. In C program you pass the file path and then you open into text and write, and similar thing you have to do. So what you have to do, you have to create the absolute path for your file. For that what we will do, folder. So folder, if you remember, I have given my folder name that is same on my local machine, and then f will come from data type, this one, and L will come label, positive or negative. So it will take one by one. So it will become something like if you want I can just print, it will become ACL IMDB first time text and positive slash slash. It will create the path by itself. So this variable path will hold in every loop iteration. It will hold the path of that file, the text file that I have shown you on system. Then for file in os.list directory, so it will give the directory path, and I am passing this directory path to this function list dir. This is a very interesting uh, function and most used if you are doing any pre-processing. Just to demonstrate this one, what we can do, we can just have import os os.list dir, and I will give some path directly. How to give say suppose this one. So I will copy this path, and I will this folder path, and I will just pass to this. So this will help you in doing your all this. So I have passed this, don't remember my path. So this I have just run it. End of. So what happened? I just pass a folder path to this list dir. It listed all the file name. This is the file in my this directory. So this will help you to process this. Anything you want to do on all files. Suppose you want to read all file and perform the tokenization and steaming. So what you can do, this function can help you to read file one by one, perform the split, that whatever we have done tokenizer, and then you can do a streaming, and then whatever you want you can do with, because now you can access your file one by one. This is looks simple, but many time we don't know how to do it, and then our problem get stuck there. So list dir is very important. You just remember anything you want to do on files one by one, anything. So suppose you have image and you want to crop image face in that image with some function. Now you want to read every file one by one, and you want to do rounding box on that face. So you have to read file one by one. Best function is list dir. You pass the directory and it will give file one by one, and you can just as a list, and then you can just loop through that and you can process that file. So I am passing the directory once time, it will give all the file name, and then again I am joining. So what I am now joining, path, this is directory and this is the file name. Taking these two as a input, it will give me the absolute path. Now I am just reading that file, this is encoding, and then as a in file pointer, and then I am reading that text file, and then this line is just appending. So what here I am doing, data frame dot append text I am reading from here, level I am reading from this level data frame, positive or negative, and I am adding. So it will iterate through all the test and training folder. It will iterate through all the negative and positive file, read the file, and text will be added. So once you run this code, so I have run this code. So it will take some time because lots of files are there. So if you print this, we are printing the review in one column and the sentiment level into another column. So this is supervised binary classification. So we will have review as a text into one column and sentiment into another column. So once we have converted into data frame, now doing any kind of processing, pre-processing, cleaning will be very easy. So now we have converted our text file into data frame tabular format. Now you can do many Panda. If you have learned yesterday, there was some Python basic course. So if you learn from there using Panda, you can do lots of pre-processing on any text. If you want to split, you want to uppercase, lowercase, many things you can do here. So if I have printed that data frame heading, so this will be something like this. This is the review and this is the sentiment, positive sentiment. Likewise, all the sample, how many 15,000, 20,000 file will be there, everything is now converted into text. So now if you want to perform tokenization on this, or a stop word removal, or any uppercase, lowercase, everything you can just write a lambda function in Panda and it will be applicable. I am not going in Panda because that will take itself lots of time. Learning Panda and NumPy is very useful. So now we have converted our data frame. So data is ready, raw data. Actually, it is not in feature form. So we can also save. So data frame have one function to CSV. So data frame, this data frame. So every time you don't have to read, iterate, and everything. So what you can do, you can just convert to that CSV file, movie.review. This name you can give, any name you can give, and just if you run this code, it will be converted to a CSV file. You can use anytime later. You don't have to do this part again, and it will save lots of time also. So I think done it. So I will, yeah. So movie review CSV. So it will generate a CSV file for you. All this in data frame. And Panda also have one feature to read CSV. So you can just read your CSV file from there. So pd.read CSV. Now again, this is simple to that data frame that we are printing here. Same thing, if you will print, it is same. If you see, this is same. So we have read text file and we have loaded into a data frame, and then we have saved that to a CSV file. Now you can read CSV file back, and whatever processing you want to do, you can do it. So this is, so I have started with basic pre-processing. I have shown you how you can do with existing data set. But now what about you want to do your own research. In research, we always look for our fresh data set. Now many people are working on COVID data set, mostly from social media or news or anything. So suppose one research problem is you want to do the political sentiment of say suppose two political party in India or in your state or anything you want to do. So suppose you want to, now for that you need data. So if it is a very global issue, then you find data set like COVID, you will find data set. But if you are taking a your own research problem, maybe data set will not exist. So suppose you want to do a research on mobile review or mobile user in India. Now where you want to get the mobile review? This was movie review. If you want to do on mobile review, you can look for some online shopping, Flipkart, Amazon. They have lots of review, 4,000, 10,000 review. If you want to work on book review, Goodread website is there. People write review there for about book. Now you need this data. Maybe there will be some people have done some 10 years ago or 5 years ago. The data may be old, or you need to. So you need to prepare your own data. So there come web scraping. This is very important to know how to scrape data from multiple sources, and this will help you to start your own research. So you can collect data from social media platform also, or you can collect from website also. There are some legal foundation where you can collect, where you cannot collect. So suppose you want to do some research on financial market. Now you can collect data from Yahoo Finance or anywhere. So in this case, what I have just for example, I have collected some news article from one popular news website, Economics Times, and I have put search term as in Narendra Modi, or you can put Rahul Gandhi, and you can collect all the news article, and you can perform sentiment analysis and see what is sentiment about these two main leaders from India, or in your local state how people are doing. So how you can collect? So the required library are very simple. You can use request library, and you can use again OS just to write. And in this there is one more library called Beautiful Soup. This is a library where you can pass HTML and it will organize. You know that HTML is not very organized a structure, so Beautiful Soup will make it more organized. So these are the library requirement. And now I will just see what we have done. So link, this is the search term. If you go to the Economics Times and you will search, this will come like this, and this is the root URL. So taking just an example, Economics Times. Now I have created some function. So what I will do, I will pass some title and I will pass some data, and I will write to a txt file that you saw in last example. So that I am creating something like that. So again, fname os.path join. You remember from previous example, this is very important to create output directory. It will take a output directory, and title, whatever title is there, that txt file will be created, and then we will write the data into that txt file. So this is a function that will take title of that news article and data, and it will write back to the txt file that you have. So how output will look? Output will look something like this. So this is what I am doing. This will be the final output, where I will write the date and time, title of that news, and the news body, and the URL also I am storing. So this 4 field I am trying to collect from that a script. So let's go back to a script. So and then create CSV. I'm also creating a CSV file for all those things. So this is very important a link, where we have also used article. Article is a module where you can scrape a news article. So header. So when you are doing web scraping, sometimes some website block a scripting. If you are connecting to a website using a script, they will just block. So what you have to do, you have to pass proper browser header. So this is the, I am just trying to add this header to our code. So when I will connect with to Economics Times, it will consider our request as a web request other than a script request. And then you can just make a link, whatever link request is coming, and header, and you will get the data. So I am just getting the link of every news article and passing to this function that will connect to that link again and extract all the so beautiful Beautiful soup will pass that HTML. Then we'll find the time that you saw in the top. Then we will do the some cleaning part, and then we will take the data, parse the data, and everything is ready. Then I will write to CSV file, and again I will call create CSV file, this function. So these three function, and then this is the main function. I will run the code and show you the demo. So data extraction, I will pass the search link. Search link is our this link where I am searching the term. It should depend upon different website. In this news, they do like this. User agent, I get the first search page, parse, get the text file, parse into beautiful soup, and then find all the tips. So this is where you have to work a little bit, where you have to see the particular, every website have different structure of their page. So then you have to find out how the targeted data, whatever data you are targeting, how that is stored into that web page. You can just do the reverse search into source of that page. So suppose economics times. So this is that website. Every website will have different structure. If you search something, say suppose India. So this is the article. Lots of article came. You can just go to the accessibility and view source, inspect, and then like this it will show you the backend, and then you will find out how this website is organizing the content you are looking for. So I am looking for this content. So this is the main link of that news, and I want all this data into our text file. So you have to, for every website, you have to go manually first time, see how the website have organized the content. Once you find out what the structure, what the HTML tag are holding this, then you can come back and you can use your code. So I find out it have a div attribute from HTML, and they have something called class and each story. Every news is into each story. So class name is each story. So what I will do, I will find all such div tag that having class name as each story. This is again different for different website, different kind of data you are looking for. So you have to first find this information. Once you find this, other thing will be very simple. So once we find this, now within that we want to find the link. A is the anchor tag. I want to find href. So I want to find the individual link. So this is once we search the page for some key term. Once we find, now for every news, this is one news, this is another news. For every news I want a complete URL like this. This is the complete URL. So I want this URL. For doing that, what I am doing, I am just parsing that page after this and looking for that anchor tag. Once we get the anchor tag, then it will be easy. We just find the header tag, we just replace little bit, and then we make a new link from that root and the URL we find out, and then we just call the create article, where we are passing this new link and the title. So create article is this previous function. It will have new link, news link, and the title will pass. Again it will visit, this new link is nothing but this individual news item. It will visit there and it will get the this data, it will get this timing, and it will get this title, and then URL also. This four information it will scrape from that page, and it will write back to a text file. So likewise we will do. So just I will run it one by one. Hopefully it should work. Yeah, so this is just function call. All function call is done. And now this main function, before doing main function, I will just try to rename the file so you will see it is working or not. Rename et2. This is already I have done previously, so I am just renaming this. So we'll see it is working. It should work. So now main function I am calling. So main function, this is main function. Now here I am just creating that economics times directory, say suppose text. So and then just if this is not exist, it will create, otherwise it will not create, just a precaution. So now I have run. So what it is doing, it is visited this term, it has searched this term, find out the main URL of all the article. It find 5 article in that search term. Now got the article, return it to the CSV file also. So now we should have 4 file in our folder. So this is the newly created, all these 5 file I've created. If you click, all this data will be different with time data. Now this information is very useful for us. So, and I have also created this.
nalla photo goruda.
So this is this. Ma'am, your mobile is on. So this is your. So yeah, there is. Yeah. So now in this way we have created our data set. So in previous example, in sentiment analysis, we use existing data set, and now we have collected our own data set. Now if you want to do, you can again taking this folder economics times, again you can start from here. You can change this code and you can take as exercise. You can just change this library to that directory name to this one, and there is no positive negative. You can try to read those file and convert to df. You can just find to this data frame by using your newly created this one newly created file that you have done. So this is how you can collect your data. This is one example from one website. You can collect from financial data from financial website. You can collect social media data from Twitter, Instagram, Facebook. So according to your research problem, you can collect data and then you can do all this processing. So this is how you will process the text. Yeah, so that is done. Yeah, someone is asking for code. I think I will share this code, but again this will not work for all. You have to make changes, and if you understand the process, it will work. So I have done for some 10 newspaper for some research work. So for every website their structure is different, their search term is different, so I have to do that for all website. So I will share this code that I have demonstrated. You can use, and then you can just, this code is not used, so you can just change according to your thing. I have also done for Flipkart, but you can try it there also, and you can collect data. Yeah, so then yeah, so from there, now this was just a collection. So whatever we have collected from that review data, now we can also perform the same thing that we have learned in earlier. So just coming back to our example of tokenization and sentiment analysis, again now this code look familiar. So before going further, I can take question. If you have any question, in you can ask or you can type, and then I can take questions. Yeah, there is any question? Hello. Please show code in line number 35 and 36. 35. Where is line 35, 36? Can you be very specific, Munna Kumar? Line number or cell number? There will be no line number. Okay, this one. 35, 36. You mean cell number. This one? Yeah, 35 cell. There will be somewhere 35. You can specific, you can type what you want to see. I can just take question and then I can move further. So I will just
Sir, can you speak?
Yeah, I'm just thinking.
Can you on the mic and say from where you have doubt?
Yeah, So I think there is no question. 35, 36 I am not finding. This is 34 and 30, 17, 39. When you run cell in different order, the cell number will be changed. So now 32. So I will just see where is 32. It is depend upon the order of running. 30.
So they're asking to see line number 32.
Not line 32 cell number. So I have to see where is that cell. 32 cell. There is 33. 33 there. 34 is there. 32 is not there because when we run cell in different order, the numbering will be different. So anyway, I will share this code so you can have, if you have any doubt tomorrow also. Line 14 now. Yeah, 14. Yeah, this one. Okay, this code, if you want, I can explain. So this is just a Python code. Don't get confused. So this is word list. All the words are into a list. Okay, this is word list. And then what we are doing format. This is Python new printing syntax where we can have all this space and everything. This is a spacing we are giving, and then we are saying that format. It will go to first heading. This one, this heading will come from there. This is just a structure. It is something like template. On the template, now going through the word list each by one, and then just formatting this one. So this will be converted like so. This is just a template formatting. Yeah. So all these functions are being called, and that formatting is passed. So this is like in how we do in C, F, and the space we give a space like 0.2, then it will have like 0.2 precision and a space everything. So like that, now Python have this print format. So passing this template to this print, and we are getting this well formatted output. Yeah. So there is no question. We will move. So we have learned tokenization, we have learned streaming, we have learned.
The question is asked in chat session, sir.
Yeah, so we have learned streaming, we have learned how to is a space. Yes, that is a space. You can look into that format. This is very nice Python funcs format issue. So you can have as like placeholder also. You can have a spacing thing also. Many things you can do. So yeah. So now we have learned tokenization, we have learned streaming, we have learned we have learned how to remove a stopword, and we also learned how to load text file and how to collect our own text file. Moving that, now taking from previous example, this code should look now familiar. We have NLTK again, we are calling the word tokenizer, and now this time we are not using any dummy one line text. Now we are trying to parse all the data frame, the review column. We try to concatenate all this to separated this one. So all will be like separated review. Now it will be converted to this one. So once we have that review, now we are trying to split text into tokens. So this is the same word tokenizer, and we just pass this review here. In this review, we are just concatenating everything into one big string, and now we are passing to this. That's why I say when we write a normal Python code and when we are using a function from module, it will be faster. So now see how many 50,000 or whatever files were there, all are in this review separated by a space one from another, and then we are now just passing to this tokenizer, and then we are taking. So token will have all the word, individual word. We are making it set. So set will have remove all the repeated words. So it will only keep one copy of every word or token. So it will have. So that's why we are going vocabulary. So now, if you print the length, it have total. I think 1,94,000 word in that review database. So you can see this is very interesting. All this word, which word came how many times, if you want to collect, you can write your Python code. Again, time complexity will be very high, but NLTK have this frequency distribution or it will what it will do if we pass the token. So here we are passing token, not the vocabulary. So all the words, how many times it is being repeated, just we are passing the token, and this NLTK frequency distribution, it will just copy all the word frequency and it will return you the dictionary. So now we have this dictionary. So just trying to print. In this we are doing passing the dictionary. This you can just print dictionary also. If you want, I can just frequency distribution, it will just show the object, or if you want we can do for the frequency distribution terms. But it will print all, so it will take lots of time. Just you can also see value of all this. If you do this frequency distribution, it is dictionary, so it will just give you the key, like the how many times value, what is the value, like 1000 times, 2000 times. So in this case they are just trying to print the sorted top 50 words. So they are doing a sorting on the key. Okay, they're getting the item and doing a sorting. After sorting, they are just trying to print first 50. So if you see in your corpora, there are these 50 word that is most occurring. The, because we have not done the stop word removal, comma, full stop, and these all are useless character that have no meaning. So in a stop word we will try to remove this, or we will try to have cleaning of data where we can just replace this with some space, or we can just remove this all kind of thing. So this kind of pre-processing you need, cleaning of data you need. So once we have printed that, so we will not print this, it will take I think too much time. Yeah, so it is, I have run that cell. So it is now trying to convert that column of that data frame into a text, and then passing to the tokenizer, parsing that tokenizer, creating frequency, everything. So it will take little time. A star means it is working. So if you have done downloading the data set and you have local setup or Colab, you can also try. So let's it's working. Once output will come, we will discuss again. So now similar thing, all code are from a starting. That's why we have started with basic, where we have shown you how to call a stop word and how to filter. So similar thing we are doing. This code is from same previous one, and we are just passing token. So now this is the, we have removed the stop word, and then we are just printing the token. So from that 50 token, now we are again printing after removing. Still if you see, so this is the output of this code. Still it is working. So I will just stop that. So we got required output to understand. So if you see, this is the frequency, what came 6000 this time and came this time. So this is the, this code, this is the key and value pair. So dot is 46,000, no, 4 lakhs time dot have came every sentence. I think that much sentence will be there. The cast, this is the frequency, and based on this frequency, this line is sorting that and printing the top 50 that I have shown you. So that is the previous code. Now you can have a stop word, English a stop word, and try to remove. So you see there is capital T always coming. So what you can do, either you can make all the string a small case, lower case, or you can add capital THE also into your stop word. Either way it will work. So you can remove. Then you can also remove dot and this all thing, and then you can clean data according to your need. So we are doing this thing. Again, one way of showing how which word having what frequency base, you know, the word and their frequency, that is perfect for creating something called word crowd. This is not very useful thing, but just to understand your data, this thing also people use, that is plotting all the word frequency as a word crowd, where the number of, based upon the frequency, the size of word will be depend. Like if it is more frequency, the word will be bigger, and different color they use to just show how. So you can just also plot. So this is again some other local library, word cloud, where you can import. And then I'm using matplot. This I think today third session will be on matplot, or maybe tomorrow, where you learn how to plot the diagrams or figures in Python. And then already we have frequency from previous code, same code is there. Now you can just pass to word cloud this frequency you can pass, and then using matplotlib I am just showing that word cloud. So this will look like, so this is without cleaning again, so all the angular bracket, all the this thing is coming. So this is one way to see how in this, if you see, movie is very small because movie is getting hidden in the noise of data. So this is called noisy data. This is a movie review, acting, bad, these are the good, these are the keyword we should be looking for, but due to noise this is getting in background. So our task as a test processing engineer or researcher, we need to clean our data, what is useful and what is not useful. So we have to clean the data. Anyway, in now modern deep learning based text mining, many things are being taken care. So but still you have to clean this if you are using traditional machine learning. So again, now this is training and testing, that I will come again back to this slide, and then I will show you this once we come to the training part. So for today we are just focusing how we can load different kind of text. So now I think with this much time, what I was trying to say, how you can load your text data, how you can collect text data, how you can do the cleaning and pre-processing of the text data. Once you have text in this format, that is very simple to use Scikit Learn or any other module to train and test a split and then train to model. So that we will come back again when we will do the feature engineering and the training part. So any question at this junction I can take, or I can move. If you have anything, and you can type in chat, or I can move to another part. So organizer, how much time we have in this session left?
So we have 1 hour more.
Okay, that's good. So we have 1 hour. We'll try to cover as much we can for image and audio. If you have any question, you can ask now about text processing or anything. So I have not done feature engineering or training. We are just focusing mainly on data part, how we can load, extract, clean the data. So we have done the text. We will move to next part. Yeah, any question, I can take it here.
Participants, any question?
No, sir, no question.
Okay, someone have put query. So we are not sharing any. We are not sharing anything anyway. If I will share in chat only. So yeah. So now moving to another type of data. So we have done this text processing. After that, if we'll go for text feature representation. So if it is everything process clean and everything, then you have to decide what kind of feature representation or feature set you are deciding. So I will share that paper. So when before tomorrow I will go to training and feature extraction, you should be familiar with what are the different kind of features that will help. So what we do mostly, now we have unique word. So what we can do, we can vocabulary already I have shown how to create, and then we can go to either make all the words in a unique words in our data set as a feature, and then every document will be represented as a 0 1. Like if word is present into that document, it is 1. If it is not, that is 0. So that is called 0 1 representation. But that was not very useful, and maybe there will be lacks of unique word in whole corpus, and then in document will be only 100 words. So all other will be 0. So this is not very useful, but people have used, and there are some method to compress that we will come back. Or now people are also doing how many times that word have come. So that is like frequency, and then based upon that frequency, now we have different kind of feature like term frequency, and then we try to see what is the size of that document, and then we divide that word into that total words in that document, that give us inverse document frequency. So then we multiply this inverse document frequency with term frequency, and we get TF ITF. So these are some feature used in traditional machine learning. Now mostly we use deep learning based. So this is one way. So this was earlier. Now Google and all, they have also tried to do word to vec. They have converted an embedding. So we'll see it when we will come back to it. So now after image, we have audio. So audio feature is very important again. So suppose now we have personal assistant Siri and all this, where they understand our voice command and everything. So we do lots of machine learning based upon audio also. We detect song, we classify song, we detect any noise, and we take action upon that. So there are lots of audio processing, but again, as text we cannot pass any audio file to our machine learning model. So again, similar thing we have to do. We have to know how to read the audio file, what kind of feature or representation we have to make. So this paper that I have shared. So audio, we have like a general sound classification. We can have environmental sounds. We have a speech. We have music. This is from that paper I have shared. I will share. So we do audio input. We do something called windowing. We just divide audio into different window. We extract the feature and then we perform audio analysis. So like these are the different kind of, if it is a speech, how how the timing will be done, how the windowing will be done. So this is all if you are working on audio engineering. Many of you will be from physics. If you have better understanding of audio, their physical property, their time and domain frequency, all these things, if you know better. So again, in machine learning, it is important to have domain knowledge also, although there are deep learning that is training now without domain knowledge also. But if you have domain knowledge, you can direct those neural network or machine learning model or the future engineering part better, because you understand that domain particularly better. If you are from audio, if you know what is the meaning of long wavelength or what is the jumping in that diagram, so you can understand better. So domain knowledge is also important. So audio character, this is all from paper that I have shared. So type of audio unit, and there is something called what is the harmonic content. So every audio have different kind of frequency and wavelength, so that depends. So this all information will go when you will try to do the feature engineering. If you don't have knowledge of this, then you can just use some library, but you will not understand. Like I don't work in audio, so I don't know much about this characteristic. When I will try to train a model, my model will work by default baseline, but we will not able to improve or we will not able to do audio engineering. So just this is all this feature. There are lots of feature people have collected over time from research. You can also see, and now also people are proposing new feature on audio. So my aim is here how you can do this audio processing. So for audio, we can do very popular is librosa, and for deep learning we have also torch audio, and scipy io also is there. So from python we can also use scipy io, where you can use to read audio and everything. So yeah, so we'll try to go back and do some audio thing. So this part I am just trying to how we'll do the loading and everything. So yeah, for audio, yeah. So again, for audio, this is one tutorial you can follow. I will just share. So this is again one tutorial that you can follow along with in your collab or local machine. So in this, I am just trying to use torch audio. So this is from your one library. If it is not installed, most of time it is don't come in default anaconda also. So you know how to install, like I have shown you previously. You can just install by similarly exclamation pip install torch audio. If it is not installed, it will install to your library, existing library. So torch audio for audio processing. And now I am using a file common voice. This is from a very well-known data set called English language classification, that multiple language country, they have a spoken English and they have collected. It is called Mozilla. This is very popular, Mozilla voice data set. So you can also try for your research also. This is very popular database. They have collected from different country. This is very large. 65, and they have like multiple language support also. So what they have done, based upon this, they have a very website where people can donate their voice in their language. So for English and many languages they have. English, it is very good, so they are 65 GB, and they have multiple country support, so like United Nation and UK, African, Hong Kong. So this kind of country base, they have collected the audio with different age range. So this all data set is there. You can just download and do a if you want to do something in that. So in that case, I have that data set, and from there I have just used one audio file in this one. So this is file path. This is in my local system. If you are doing in Colab, you have to upload that. So that one, that is the audio file. This file, it is in same folder. So I don't need whole complete path. Sometimes this also create problem. In tutorial, I am using only file name because my notebook and this file is into same folder. If you are keeping, say suppose this data set is large, you are keeping somewhere else, maybe server or somewhere, then you have to put the complete path of the file. So let's start. So we have torch audio imported, and then file path, and then you can also use Librosa. As I said, Librosa is another very popular library for audio, especially for audio analysis for machine learning. You can read, write, you can extract feature, different kind of audio related feature you can extract. So now I have imported. In this case, I am using Librosa. So again, code is very simple. So what I am doing, I am using Librosa load file path, that is my audio file, and SR, we are just not passing any rate, sampling rate, we are just keeping it none by default, whatever it will take, and then it will give us sample converted into numbers, and sample rate also it will give us. So I have not passed any sample rate, it will tell us sample rate. So sample means now audio file will be converted into a numpy array like this. All the value whatever in that file, it will be converted. So now audio whatever we are listening, that is not audio, that is a array. So that's what computer will understand. And sample rate, some sample rate is 65,000 also. In this audio it is 48,000. So this depend upon pitch of the sound or some other constraint. This is very important when you are creating feature or trying to classify. So I don't think there will be any clear problem in this. So load, once you have done the sampling, now you can also use SciPy. So I said three library: Torch Audio, Librosa, and SciPy, that Python scientific library. They have also input output module, so you can also use SciPy. Again, in SciPy, this is input output module. In that you have to very specific which type of file you are reading. If you are reading web file .web, then you have to import that function, whereas in Librosa and other library they just use load. So it's take out some complexity, you just pass the file, they will figure out the file type and load every file type of audio, supported audio file, whereas you have to pass it very clear. Same thing we are trying to do, we are trying to get the sample rate and sample, passing the web file, and this is read function, passing the file, again printing, same thing. So just this is to demonstrate how you can read these three library you can use and you can read your file. So once you have done this, now this is just reading the file. Once you have done this, either way you can just now plot this diagram. So Librosa have display from audio to the diagram, you can just convert, and then matplotlib to plot that one. So this is just information. So this is previous line, how to load. So once we get the sample, we are initializing the figure plot 14 into 5, and then we don't have to do much. Librosa display web plot, whatever sample I said, sample having numpy array, that will be audio will be converted into numerical representation of multi-dimension or depending upon the this one, and then I am passing sample rate as whatever sample rate we have. We know that sample rate here, we have got this sample rate, that is 48,000. I am just passing that 48,000 to our this web plot. So now Librosa will plot this one. So this is from audio how you can plot a web kind of thing. So we can know, and if you are from audio engineer, you know that there is high pitch, there is like silence, or there is low pitch is down or something like that. And then based upon this, if you are doing feature engineering, we know that this part is silent, there is no from 0 second to 1.2 second there is no voice, so that will be just a noise to our feature. So we can just crop our audio from there, and then last also we can crop. So this kind of thing also you can do. So now either you can do in audio file directly, or once you have read that audio file, then you can also do the cropping. Cropping is nothing but taking the subset from this sample file, and then it will be cropped. So this is converted. And if you have that one, then you can also just read that. Like in Python we have IPython, you can just display audio also. So this is just same file, just trying to read that file on that one. So you can now print sample shape, that is the sample rate and data type. So that is why I was saying multi-dimension. So you can just see the dimension, all this value, that is a numpy and DRS. So this is, I am going very basic because I just want to know how I want to tell you how audio is being processed in our computer. So this will be nothing but all audio voice will be converted to numpy and DRA. And then once you have done this, now first feature, there is like you can just get this feature set where a spectrogram, you can just generate a spectrogram. So in librosa, this is again same line, loading the file. I have just doing for making every individual cell unique, I am just doing one every time. Otherwise once you have load that file, you can just use. So now I am passing a spectrogram. To create a spectrogram, I am using this function from librosa. So librosa is dedicated for audio processing. So we have this function where it will convert sample, that numpy and array, to this. So now this is very important. Every function, how we will know? We cannot learn everything by this thing. So what you have to do, when you go to the tutorial, they will say librosa take input parameter numpy array, that is the sample. So you have to make sure when you are passing this should be the numpy array. So loading or some other method or something. So then convert this sgram. Then we can use just librosa display a spectrogram, and then this is a spectrogram. It is just plotting your audio signal. And if you see, there is like this kind of thing. So earlier people are start using this spectrogram for feature extraction. Now you can pass to any image processing, and they will take it as an image, and then based upon this dark and color base, they can extract some picture. But this picture will be not very useful. People use earlier, now they are moving back to. So now if you ask me to explain this, how, what is the black, so that is like if you have, I am from audio background, I can explain it better. If you are from audio background, you can understand this spectrogram better than us. So likewise, domain knowledge is also important. So this was not performing very well for feature engineering. So then people move to Mala spectrogram. So Mala spectrogram is just improvement over basic spectrogram. So we can again just use librosa, this one, same sgram. So we have done this spectrogram. Just we can pass same to mel phase, and then it will convert to Mala spectrogram. So this one is function converting a spectrogram to Mala spectrogram. It will take a parameter, a spectrogram, a sample rate, and it will give you the Mala spectrogram. Mela scale, just a scaling that feature, and then display. Again, the display is simple. So this is just converting that spectrogram to this one, and then converting to Mela spectrogram. So this is again much better than this in a feature, in a image processing part. There are lots of black pixel, whereas this was a scale little bit, and we have now little bit more clarity about our audio, but still this was not perfect. So we moved to Mela spectrogram, and we are trying some scaling also. We are just changing the decibel scale, using the decibel scale to get the final Mela spectrogram. We are using different scale. In this we have used different scale. Use the Mela scale, that is from audio analysis. I have not much knowledge on that. So scaling we are changing, and our spectrogram is changing. Now we are using decibel value. So when we see the decibel value, this is much. Decibel is what we hear as a human. I think decibel scale is for human. So we hear that value, and then when we plot that, so that library is only to help you to do the implementation, whatever concept is there, how you will do in practical. So library is there. So if you know that what is decibel scale and how we can do, then again this is very simple. We are just converting aptitude to decibel. So we are passing that previous Mala spectrogram, and then we are passing the reference minimum value NP. This is numpy array, and it is we are passing the minimum value, so just for reference, and it will create our Mala spectrogram. Again we have just plotted. Now this have more information for a machine learning perspective. We have just remove all the dark pixel, and whatever the having more importance for audible for human, that based upon that we make classification. If we use this image, now we can just have pixel based value and we can train some model, so that will have more information. So this is your just changing the scaling. Still it is not okay. Then if you see this speech recognition, we have many other like MCC, all these thing we can have different kind of a spectrogram. So now I have shared that paper also. You can read those feature, and this all code are working. I have shared that link also. And from here, if you see, we can just try to have this sample is not defined. So this all code in a tutorial, maybe some code will not run. So problem will be only if version is not there or module is not installed, or if there is some time typo is there. So you just have to be very careful. If you know the concept, you can just try to replicate the existing tutorial, and then you can work upon that. So all this code I will share. It will help you to get started, and concept also. All this explaining one concept is like separate. So all this code is like working code. So purpose is here to just demonstrate. Even there is classification tutorial also. So this tutorial, if it is not working, you have time tomorrow also. I have one session. So if you can try today, and if you have some issue, you can ask me like by mail or something. So I can. So this is another tutorial. So this is audio processing. So again, our task is here till only data loading. How you can read the audio file, how you can process the audio file.
So we have the question in chat box.
Yeah, I am seeing it. So I have shown the data set. I have used Mozilla Data Set, Mozilla English classification data set, that is very large. From there, I have just used one BEF file. So this is the data set that is very large in size. So from there, I have used just one file. Just I will just show the data set. It is very audio classification. Sorry, open, yeah. This is the data set from that Mozilla. So this is like, sorry, I have opened the. So this is the training. So I was saying this is from Mozilla. There are lots of sample in this 2500 African English voice, Australian 1000, Canada we have 1000, England we have 10,000, Hong Kong we have 1000. So this is very popular data set from Mozilla that I was showing. From this I have taken one file to just load the spectrogram, and so if you want to do the classification, then you have to like how we do this text processing. You have to process every audio file one by one. That also I will show once I will come to that session. So this is the link, Mozilla dataset. This is available in multiple platform. You can either download from here, or you can, yeah, I will just share in chat. So this is called Mozilla English dataset. Okay, and you can use any voice. I have tried with my own voice file, and I have tried with the tutorial link I have already sent you. I will send this code also that I have run, and you can also try replicating. So two link I have shared for audio file, that is from data towards data science, and you can take any audio file, web file or any mp3 file. That mp3 will have different structure, how you will convert. So you can just try with librosa, scipy.io, and audio torch audio, and you can use either that tutorial from link, or I will be sharing this file also. So if you will play this, you will understand how audio file is being loaded. So today's session I was focusing more on how we can read all these different type of format and how we can convert to different format. So we have done with text and audio. So I will move to image. I think if you have any question you can ask. So after working with audio, you can have image data again. This file you can search by your, or I will just share all the downloaded paper also. So this is very good review where they have review all the image feature and representation technique. So in image, you will have a separate session also, computer vision session, I think tomorrow, where they will discuss more about image and video feature. So image have been like very revolutionary research in machine learning. First, we have traditional machine learning where we'll try to do all this feature extraction, and then suddenly deep learning. Now we have lots of transformer and neural network based feature, already trained feature, ResNet. All these are trained feature for classification, object detection. So that is like totally different domain, but still we can have like previous feature is also very huge, like we use color descriptor. All this color have some information about this one. Still we can use for improving our model if you are using traditional. So this is from that paper that I have cited. Then we have a textual feature like a special feature, and this all which are still we use for many problem. But if you like autonomous driving or all, there they use now deep learning based that neural network learn that feature by itself, and there are lots of trained model also. But other than a big project, if it is like a small classification problem of image, then we use this kind of text feature like image feature. So this is complete based upon the shape, different kind of shape we have information, and we try to, this is all from paper. For this all, either some of the library will have implementation. If it is not, you can write your own implementation. But if it is very popular feature, the library will have uh, function for that. So for suppose gist feature, so how this is a image, now we have like black out the other part except the sky part is okay, then see. So similarly this kind of lots of local and global feature we do. So this is again one kind of image feature that was very popular, and now in deep learning also people are using similar kind of feature. So this is image feature. I will share that paper. You go through all the paper now if you are working in image. So you have to learn first how to load image, what are the different representation of image, what are the traditional image based feature. So Opencv and all other library will have method to how you can process image, and then when we will come to the feature extraction, we will see how we can do the feature extraction. So this is image. For image also I have some basic demo, and the main library is like Opencv. We have like Scikit Learn. We have also one library called Scikit Image that is fully dedicated to image processing. Then we have PIL, Python Image Library. So that is also very dedicated for image processing. So yeah. So this is like one data set. Again, I will share the tutorial that I have adopted. So you can also, in this tutorial, lots of mistakes are there that I am sharing that link. So you need to be very careful, and on this whatever I will show, there are many mistakes that link I have shared. So that is not like fully functional. That will not run by itself. So you have to. And then the data set I have used, that is called scenery classification from Kaggle. So you can download this data set. So this is image data set, very popular for scene classification. So now if you want to use again Python for this, then we have Opencv Python binding that you can, if it is not installed, you can install using pip install Opencv Python. Again in notebook, if you want, this will install your Opencv. So once you have this Opencv, all other library will be available with default setting like Panda, NumPy, OS, and CV2 is this one, Opencv. Opencv, if you want to import, you have to CV2. So that is the binding for Python. So now once you have done this, library. So now in this, what we are trying to do, there is a data set image classification released by Intel. There is scenario 5-6 scenario, jungle, building, sorry, forest, building, and all this classification, and there are thousands of image for that. So you can download that data set from there. And now what we have to do, again, process is very same. We have to read image one by one if we want to do some processing, and then we have to, let's say suppose we want to just extract all the pixel value, so we have to just take the pixel value, but we have to read image one by one. So we'll try to understand this. So just I am reading. So I am doing, so first, if you are following the tutorial and if you are on Linux machine, the path should be changed. In window, this is backslash, whereas in Linux, this is front slash. So this is like this, you have to change. So this, my image are in archive, segment train, forest. So this is this organization, this one, archive, then this one, prediction, test, training. In that also there is this folder. So that is the path. So archive, segment train, and code in same format. So I have not passed. So I have just passed the path. This is not absolute path. This is the relative path of my image data set, where relative means the my code and this data is into same folder. So they will consider from this previous, like image and all this path will be relative from there. So image folder. Now I am just trying to pick randomly 5 image and I am trying to print. So np numpy random choice, again you remember list directory dir, it will, if you pass a folder, it will list all the files. So I am passing this folder, it will list image in that folder, and random choice will just pick 5, one every time. So that loop will go 5 times, and every time one random image file will be picked. Then again, OS path join. If you remember, these two I said very important when you are doing anything repetitive job on your operating system where you have to iterate over your files. Then OS path join image folder. So this is image folder, this path, and whatever file name I will get. So suppose image1.jpg or something. So image1.jpg file path I will pass to this OS. They will generate the complete absolute path here, so that will be easy to open. So now using this library, I am just using mp mread. So if you remember, I have matplot image. So here I am using matplot image to read the image file. So matplot read and image path. So every time a image will be read and then just plotting into all image. So that 5 image will be plotted like this randomly. So maybe I will try this. This image, if you remember, maybe it will change. PLT is not defined because I have not called this. So if you remember, see, this 5 image have been different than previous. So every time I will run this, 5 different image will be picked from that data set, and it will, every time I will run, different image should be there. So that is picking 5 image from the image data set. This is just to demonstrate. It don't have any use in machine learning, just to see how we can have randomly file, how we can read file one by one. So we are doing this one. So once we have how we can read, and here I have used matplotlib. You can, for image reading, you can use any library. As I said, Opencv, PIL, you can use PIL, you can use a Scikit Learn image. So these all are image processing library. They will give you lots of function to manipulate image. Then now we are moving towards how we can create data set. So in image, we have to be very careful when we are using image based feature. We have to keep the our width and height constant. Then only you can extract the pixel. If one image is 200 by 200 and one is 200 by 100, then the number of pixel that we will extract, the array will have some value empty, and that will create problem, null value. So what will happen, all the image processing, we try to keep our image size same. Even if it is not that much size, we pad with some value, 0 value or something, but size will be same. It will be helpful to pass our neural network also, and if you are extracting pixel value there also, it will be very useful. So in this case, we are fixing our width and height to 200 by 200. So just initializing two variable. This is nothing to do with just Python way to assign two variable to value, and then printing this. And now what we are trying to do, we are trying to create the data set. So creating the data set means we will read all the file one by one from different training and testing, and then their level also will try to achieve the level from that. So first we will read. So this is just a function. Image folder will pass the complete image folder. We are trying to read all the image as a array. So again, like text, we will, like audio, how we read the audio file and we have a numpy array. Likewise in image also, we will read the image and we will try to get the numpy array for every image. So that pixel value will become element in that array. So that will be 200 by 200 numpy array and every pixel value. So there is something like RGB, and then there are more channels. So sometimes we need to flatten that image. So many things that you have to do when you are doing image processing. So if you are a machine learning engineer, there are a specialization. You are like NLP, you are working in NLP, so you know much about NLP processing. If you are audio, then you know much about audio engineering. And then if you are in image or vision, then you will be like working with audio and image together. Or like me, I am work on machine learning or cyber security. Then my domain is that I use either of this for my problem, and how from domain knowledge I bring this thing. So if you are from image, you have to know basic of that image and computer graphics and how image processing work. So having said that, now from previous this code also looks same. Again we are listing the image directory. We are joining all the file from their directory one, and then directory one and file. So this will be one root, then the training will come, then file name will come. So that will become image path for training. Similarly it will do for testing also. So this will come one by one. Then we'll just, this time I am using CV2 computer vision for reading the file. So I am reading that file and I am saying convert that to RGB, BGP to RGB, and we are just converting that image, and then I am reading that image. Now after reading that image, we are resizing using CV2 resize function, passing this image. And if you remember, we have fixed our height and width to 200 by 200, and then we are also using some interpolation, and for that also we have some value from CV2. So this will make our image ready for feed to machine learning model or anything, or deep learning model. So after doing this, now this is converted to that image is processed, resize, interpolated, everything. Now just convert to array. So this image is now converted to NP array. Sometime CV2 also may convert, but to make sure we can just convert with NP array function, and then now image is converted. This image variable is just a numpy array representing our image 200 by 200 everything. So now we can also set the data type. We are just using float 32, and then this line, if you follow the tutorial, they have said this is called a scaling. If there is like pixel value from 0 to 255, after doing this, this is very useful when we are doing with numpy. So imagine nothing but numpy array. When we are doing such kind of division, what we are saying, go to the every element of that array and divide by.
The question is there in chat box.
Yeah. What is x and y? X is showing in image. That size is that the size of image. That's all. 0.25. Nothing is in this. We are not plotting anything. So just this size of that image. This is just x and y. We are not in this. Just we are showing the pixel. We are not doing anything about that. Yeah, that will be like 200 pixel or 150 pixel of that. Yeah, that is just showing that 0 to this one. There is no meaning in that scaling. Whatever pixel will be 0 to 255. It is not the index also. It is just showing that pixel, and this is just random. When you plot that diagram, they will take the default numbering as a x and y diagram. That's why we have not put any level in that diagram. That is nothing to just this code is for, we are plotting that image, just showing as a matplot. So okay, this random 5 image, how it's look. So we are here. So now here we are doing the processing. We are just scaling the pixel value from 0 to 255. So now it will be converted to between 0 to 1 when we are dividing that value. So now every value will be between 0 to 1. Then we just creating the large data set, appending all the images. So every image will be read, rescale, and then append to the array. And then the class name will come as a directory. Whatever class name will be like forest, building, it will be append to the class
Sir,
name values.
question in chat box.
That is just random. It is not increasing, decreasing. It is just from that matplotlib. I have never given some thoughts on that. This is just from subplot. So they have just taken whatever default will be there. So if you want to know x and y, why increasing, decreasing, it is nothing to do with image. It is default behavior maybe from when we plot on coordinate, x coordinate is increasing and y is decreasing. So this is just random, nothing to do with image. I have not given much thought. If you want, I can just look into and see why it is increasing and decreasing. What I'm saying, there is no meaning of data scale in this. Maybe the default behavior of plot will be something like that. I have to check that. Yeah. So now after running this function, it will read all the folder training 4-5 classes, read the image, convert into 20 by 20, convert the pixel value, rescale between 0 to 1 by using this line, and then return the n dimension. Whatever the n is the size of how many image we have in everything, and then it will be, if you run this image data, and this data set will be created. So it will again take time to run this. Yeah. So then all this thing will be converted to a, so now we taken the image and converted to numpy array where we have one class level also. So now for supervise, that is very useful. All the image is converted to npy array and one column will have the class, so that you cannot pass that class name like forest or anything to uh, model. So sometime we have to convert. So what here we are doing, just taking all the unique class names. So in this case we have 6 classes: building, forest, glacier, mountain, sea and a street. Just passing to our dictionary comprehension and trying to get a dictionary where every will get one number. So building will be represented as 0, forest will be 1, glacier will be 2. So this is just to make our model work. If you pass this value, class name and image data to any model machine learning classifier, that will give error that a string, it should be number or a string, that error will come. To get rid of that, most of time we convert our class name as a numeric representation. If it is binary class, we say 0 1 class, 1 another class, likewise. So we don't know what are the levels, so we are just using this one and creating 6 unique value. Now this is, we can pass our class name list range 1 by 1, and then from this dictionary, if it is building, that target value will become 0. If it is forest, it will become 1, likewise. This line of code will process, and then finally our y, this is also called y variable, that is your class level, that will have 0 1 to 5 value according to the input. If it is building, it will be 0. So now after doing this, we will have all the image converted to numpy array and the level will be 0 to 5. So now that is ready for any machine learning model and converting that one. So also you can use PIL as I was saying. So PIL, you can just read image using PIL also. So these 3 library, PIL, CB2, even matplotlib or a Scikit Learn image, that you can use and read. So once you have this done, then in the tutorial also see, we can pass to the deep learning model or we can pass to any SVM and we can classify. So that is when we will go to classification or feature engineering, we will come back to that. So with this you can have now image also ready for processing. So any question if you have, you can take it here. Yeah. So image data. Yeah. So if not, then I can continue with presentation. So this is like summary. So we were doing something called bag of word, text for feature, we can use NLTK or Hugging Face or any natural language processing. Then image, some popular is like fog feature, we can use Scikit Learn image, Opencv, PIL. And then video, most of time video is again converted back to frame by frame to image, and then we perform whatever image processing we are performing. That we also do some modern time, we also do some processing on video directly, that you will have some vision session tomorrow, so you will know more about video there. Then audio, we have feature like a spectrogram, mala spectrogram, so use Librosa, PyTorch audio or SciPy.io. And then as my area of research, I work on malware, so there I have input as a binary file, exe file, or Android file as a apk file, that have nothing to do with all these four machine learning traditional data types. So we have to think our own how we can process, what are the features. That is like my research and my domain, people are working, they have considered header information, all these things they have done. And for us, we have some library, so this also will demonstrate my area from a start to end, how we have done research, what are the result. So that also I will demonstrate tomorrow. Then meantime, so these are different. So now with this basic, we have learned how to load or process any data type, text, image, and if you have video, you can just convert video to image, and then you can process audio. So these all are the basic data type that you will be using for any machine learning model. And then so now why, so whole purpose of today talk focusing more on data was this. So now today, if you know one of the best scientists on machine learning, Andrew Nage, recently last year they have started this thing that is called data centric machine learning. So what he is arguing, that now we have enough machine learning algorithm, they are performing well, so we have to go back and we have to look into data. We need clean data for supervised learning, we need clean labeling, we need clean data set. If we are doing that, we are able to achieve our performance better with same algorithm. So if you see many competition on Kaggle is a machine learning competition where you can win award also and money also. So there are lots of new problem and data set also you can get. So if you see there, they focus more, they give you data and they focus more on how you can improve the performance of algorithm, how you can write new feature or something. Whereas in this Andrew NG, his emphasis more on now data. You just clean the data properly, label the data properly, and you will see the improvement. So he have launched this competition also. That's what I want to share, and that's why I focus my talk on this data part mostly. So this is the competition link that is called AI. The deadline is approaching, so you can try. You have enough time. So I have shared this link. So in this competition, you can register. So what is the baseline? So they have given 62% baseline, and they have given use handwritten digit data set, and on baseline algorithm the accuracy was 64. Now that is released to public, and public don't have to do anything on training or feature extraction or any feature selection. They just have to work on image. They can add image, they can rescale image, anything. You have to just submit the data set after doing changing. So if you see, these are the improvement. The top all are at 85. So nearly 20% of the performance came only from processing the image properly, leveling the image properly, the removing the noise, removing the faulty level. All this, if you are doing, people are still, it is ongoing. I think last date will be in September sometime, September 4. So some 10 days is there. So 20%. So the top people they are running, they are on 20% improvement just to do the proper labeling. So that is data centric AI, where he is arguing, and there is course also on Coursera for this thing also, where he is arguing. If you listen this video, he is saying on his experience of 10-15 years of machine learning engineer in various scale, he learned that we need clean data, we need proper level data, and then performance of the algorithm will improve. So in this competition, you can also look, they have provided the data set, handwritten data set, 10 class, and they have provided the code. So you just have to work on image, you don't have to touch that code. You can add some image, you can add more label, or you can have more image. They have given some 3000 sample, you can go up to 10,000 samples. So you just have to add image 300,000 to 10,000 and you have to label. If you are able to do that, then you submit and then your performance will come here. Like they have proper tutorial, so you can try this. This is very good. So this is one thing. And then second is, so data centric AI. So that is my attention was to put more important on data, how you can process data properly. And if you know Python and other language where you can play with data properly, and if you have domain expertise, then you can have better result with existing algorithm itself. So that is the trend. Then something called data fusion. So data fusion, what is happening? So data fusion, now we have text, audio, video, image we have learned. So some task, especially on video processing, in video you can get text also, you can get image also, and you can have audio also. So a video file is combination of audio, text and video. When you are speaking, if you are caption, that is text. The audio part is audio file, and then when you take frame by frame, that is become image. So now you have three data set from one video and one problem. So you can either have individual feature and train and see how performance, or you can fuse also, take the text feature, image feature, audio feature, and then you build the model. So that is very active research area called fusion, data fusion. You can do fusion, early fusion, where you take the feature and merge and then you train the model, or you can do late fusion where you build this classifier, take the prediction and then you do the fusion of the result prediction, or you can do in between. So based upon that, this deadline is over. We participated in this multimodal sentiment analysis challenge. That was a video competition. We have some 10th rank all the world, around the world. So there, this data set, earlier they have car data set. This year they have two data set. One is for car, like this. So this is video and all these things. So you can have like we were working on this stress, where we have taken given the 70 video, where the people audio, video and everything. So this is very nice about fusion. You can look into more into that, where you can use audio, video and feature, and they have paper also, like baseline paper and code. Everything is to get us started. Now you have basic information about audio, video and text, and you might have, or you may have background in machine learning. You can look such kind of challenge and you can work. So they have baseline paper, they have baseline code, and then test on the result is also. So now you can look into this is fusion. So that's why I want to again tell that this is very important to work on data for two reasons. Now recent trend is database centric AI, and then such kind of fusion is also possible. So I think that's from my side for today. If you have any question, or I will be sharing this PPT and other thing. If you have any doubt or anything that you not able to ask here, you can just write email also. What is the practical purpose goal of using ML in image, audio and video processing? Everything. There are many applications. Suppose image. So image, one example could be we use a scanning, and then from there we extract our data. So that is nothing but machine learning. We scan the image and we read all the character by character and we convert to the text. So that is one very good example. I will show some example where you can take PDF and you can convert to audio file. So a PDF file to convert to audio file using machine learning. And then audio classification. Now there is your Siri voice command. You say Siri do this. So that is understanding of voice. Then when they understand your voice, they classify. That is audio classification. Video processing. This, like I show you that example, this video, this one. In this data set, we have a data set like this person is interviewing and that video is there. Now we have to tell, is this person in a stress or not, how much stress is there. This all we are doing into just from video information. Likewise audio information, when we are talking, like in first session when our audio is recorded, many of you are complaining and voice was not clear. I was in a stress because I have to shift from one system to another system. So you can feel the change in my audio frequency, even video picture also. So that similar thing is there. So now there are lots of application of this all audio video. Machine learning itself is very popular due to this reason that you can apply to many region. One interesting story, a small story, and I will end it. Was one student. His father was farmer and doing this cucumber farming. You can find the code also internet. So they have to, after taking out crop from farm, they have to segregate like a small, big, and different size. They sell in different price. So their parents used to do manually. So he work in some machine learning. So one day he decided to automate that process, and he built some machine learning based model where this cucumber classification is done. So now you can just put all the cucumber, go come by a bag, and then everything will be in separate basket. So likewise, lots of application in agriculture, health, and space sciences, and everywhere now machine learning is there. So that question is like good, but already there are lots of application. Matching of faces of criminal wanted person in crowd traffic. Yeah, these are the example. Lots of examples are there. Face recognition, face matching. Sometime it is privacy. So there are many issue also. That is tomorrow I will discuss some issue with legal issue and other issue with machine learning. So yeah. So yeah. So any other question? So I think we are about to closing time. I think,
Participants, any questions?
yeah, I'm seeing that chat. If it is there, I will take that chat question. If you have any question, you can mail me also. I have
Ajit
said,
sir,
yeah,
I have small doubt. So
yeah.
where from these initial challenges, whatever you have given, how
Mhm.
to track like what are the challenges open? Is there any particular site where we
Yeah.
can get these challenges?
Okay. Kaggle, you will see the phrase challenge. That is one particular thing, but there are many other challenges site also. So now, if you are in that domain, you will be mostly like coming to know. If you are like, it is like ecosystem. If you are working in machine learning and following that people, like how people follow actors and actresses, you come to know about
Okay.
their
So you
recent
have to go
release.
through
Yeah,
tweet and
yeah,
all.
yeah. Tweet and all, you have to follow. If you are in that domain, then only come to know. But this is like recent trend. If you are not
Okay.
following, means you are not in that domain. That's why you are like, if you don't follow Henry Ng, you will not know about the recent development in machine learning. He has speak and he share. You have podcast. So like many of you would have heard about AI Day of Tesla. That was last week. If you have not heard, watch about AI Day. It is like how machine learning, deep learning will be after 5 years. So he have given a glimpse last week. So if you follow that, he have released the robot. He have told about all this new neural network architecture, hardware, everything. New hardware. He is coming with something called Dojo that will have like revolutionize the hardware machine learning based training. So everything he have released on AI Day. So such kind of platform, if you are connected, then you will get this latest information about. That's what we do as a researcher. We have to be in recent trend what is going on. Yeah, so AI Day, if you follow, that is very good information he has shared.
Thank you, sir.
Yeah. Any other question? So I think
In this session,
there is
yes,
no
sir.
further.
Thank you for your practical session. It was so informative.
Yeah.
I will resume by 2:30
Okay.
after lunch.
Yeah.
Thank you.
So I again extremely sorry for my first session. That was like technical issue with my machine. I was not in my own system. So yeah. Thank you. See you tomorrow then. Yeah. Thank you.
Yes, sir.
Yeah. Thank you.
ஏங்க எனக்கு ஒரு தேங்க்யூ மெசேஜ் 2 எடுத்து கொடுக்குறீங்களா? எல்லாத்துக்கும் ஏதாவது ஒரு சொல்ல வேண்டியது. இதை வச்சு பாடம் படுத்தி எடுக்கிறேன்.